Hi everyone, welcome back to our statistics class notes. Okay, we're still in chapter 8 about hypothesis tests. And in section 8.3, we want to get down to some of the detail. We want to talk about identify two possible sources of error that we could come across in hypothesis testing. We want to distinguish between practical and statistical significance. We want to identify similarities and differences between a hypothesis test and a confidence interval approach. Okay, so revisiting small p-values, first of all, a small p-value means that our test statistic is extreme. In other words, it's far from the null. Remember, the null hypothesis is what we have p equals to some p naught based on some past information or what we expect, some sort of status quo information that we have. So a small p-value means that, hey, we got a test score, a test statistic, which is a z-score, a z-stat, that's a long ways from the null. Okay, so a small p-value means we do have an extreme test statistic. An extreme test statistic means that something, hey, unusual, therefore unexpected has happened. So the small p-values lead us to reject the null hypothesis and then also state that we have sufficient evidence, enough evidence, to support the alternative hypothesis. Now, if the conditions fail, what I mean by the conditions, I mean the central limit theorem conditions fail. If the conditions concerning the sampling distribution of the z-statistic, the z-score, fail to be met, then we cannot find a p-value using the normal curve. Conditions can fail for the following two reasons. Usually the sample size or the population is too small, right? That's the second and the third conditions under the central limit theorem conditions, or the samples are not randomly selected. And in that case, conclusions cannot generalize to the population. Now, we don't want to get too specific here as far as you have to memorize what type 1 and type 2 errors are, but there's two types of potential mistakes that can occur in hypothesis testing. So these are given in the table on the right. The first of these is that we could reject HO even though HO is true. So remember, assuming that HO is true is what we always start with. That's our basis. That's like in a court of law, we're assuming a person is innocent. Assuming the null hypothesis is true is our assumption to begin with. Now, if we reject HO, that means we thought we had enough evidence to reject HO and support the alternative. However, rejecting HO when it's actually true can happen. We could get a test statistic that's far away from the null, even though the null is true. And the probability of us making this mistake is our significance level alpha. That's why we choose alpha to be pretty small, like 0.05 or 0.01, etc. We only want a 5 or say a 1% chance of actually making this type of error. The other type of error is called the type 2 error. That's when we fail to reject HO, even though HO is false. In other words, we do not convict the innocent person in a court of law because they weren't innocent, right? We do not convict them even though they were guilty, right? That's what this means. So that's probably not as bad as the first type of error, the type 1 error, because we don't want to put away an innocent person, right? However, not putting away a guilty person is also bad too, and that's kind of what the type 2 error is. Okay, so we always try to avoid these types of mistakes, and I'll come back and I'll do an example next to discuss those two types of mistakes.